Our next speaker is Anne-Marie Walters, Bentley Systems Global Marketing Director since 2004. She is responsible for the marketing and positioning of Bentley's solutions and products. MS Walters, a chartered chemical engineer, represents Bentley on the board of the Construction Industry Institute and is involved in the activities of FIATEC. She was on the board of the Engineering Contractors and Constructors Association from 2005 to 10 and was the chair in 2009. She is also a founding member of the Process Industries STEP Consortium and has served on the boards of CIM Steel and the UK's chapter of the International Alliance for Interoperability. Please welcome Anne-Marie on stage.
So, namaste. This is actually my fourth time presenting here, and I'm delighted to be here presenting again. For those of you who saw my presentation last year, I introduced a concept called reality modeling, and I did a live demonstration. No live demonstrations today, but the technology's moved on rapidly, and I'm going to give you an update of use cases of that technology. And I'm also going to talk a lot about what we're doing jointly with Siemens around the whole digital twin side of things. So here we go. So one of the things that we noticed back at the Orlando Forum was that ARC have expanded beyond industry to infrastructure and smart cities. And this gives me a good opportunity to introduce who Bentley actually is. We are not the vibration monitoring company of Nevada. We're not the car company either, although my accent might confuse you. Basically, Bentley is a software company, and we model and simulate the world of infrastructure. And by infrastructure, we mean roads, bridges, railways, buildings, cities, industry, that kind of thing. ARC rank us in. We respond to three of their reports. First, asset reliability and software services in the industrial space. Also engineering design tools in the BIM space, and you can see we're number one in asset reliability and number two overall in engineering tools, and we're also featured in the GIS report and number two there too, in terms of everything that we do is geographically located. So we're a software company that plays in both the operations and the capital project space, simulating and modelling infrastructure. What we bring to the world of in the industrial Internet of Things is the convergence of IT and OT with engineering technology through digital engineering models. And we believe that this is a way of making sense of a lot of the information and making it easier to make decisions about all this massive amount of data that you've got when you've got good engineering information that is supporting those decisions to change your operations or to revamp or replace something. So now I come on to reality modelling. For those of you who aren't quite sure what it is, basically it's the taking of digital photographs and turning those into accurate 3D models. Last year, we integrated in with the photographs laser scanning, and we also introduced a mobile, there's an app for it type of thing, being able to take photographs on a mobile phone and create these models. Just to give you a little bit of an idea, you might remember this. We worked with Siemens to model this skid plant. My colleague Gernot there took 540 photographs of this skid and produced this reality model of their process automation skid. They'd not been able to laser scan this because there's too much glass and so on, but the reality modeling produced a pretty good model there. So basically it's providing this context of your existing assets in a 3D environment. One of the things that we do every year is ask our users to submit their most impressive projects. And I've got a couple of examples here of the use of reality modelling in the smart cities environment. Basically, this company created a smart city model of the new city in Taipei using both hybrid scanning and photogrammetry. But the next example, and the video is going to play, is a BIM application where they've gone from traditional 2D planning to 3D planning, combining combining reality modelling of what is actually there with the BIM 3D models of what they're planning to build in this city in China, basically. And you can see as the video runs through how they've combined the 3D designs of the roads and the underpasses and so on with the reality model of what's actually there to give a really good idea of how to plan and execute this project. This was, I think, the winner, one of the finalists in the reality modelling category. Interestingly, from 2016, we had 3 submissions in the reality modelling category. In 2017, we had 47 submissions. And so these 2 city examples are just a couple of examples. I have another one a little later on. Mentioned the integration of laser scanning with reality modelling, and as this video zooms in, on the left-hand side you can see laser scanning, and as you approach the model it starts to lose what you can see. It becomes very granular. But on the right-hand side you have the photogrammetry combined with laser scanning to give real precision. You can read the sign there, you can measure very accurately, you can really see very accurately. It looks almost like a video of this plant, but this is actually a reality model with a bit of laser scanning, and on the left-hand side is what a laser scan would do. Now, we're using this technology quite extensively to inspect existing assets, or our users, I should say, are using this technology to inspect assets and also be able to automatically pick up some things. And I'm going to come on to that now in a little bit more detail. I mentioned also the mobile app. We introduced this last year, basically being able to take photographs on your mobile phone and automatically create a small reality model of what you're looking at and then be able to share that with an inspector back at base. This is really revolutionizing a lot of maintenance and inspection asset let me go back. So, and it actually won an award itself last year with at one of the main maintenance conferences that happens in the USA. Now integrated with reality modelling, we've also with the photogrammetry and the laser scans, we've also added the other imaging devices like thermal imaging and things like this. And I'm going to come now to some examples in the telecoms industry. And I think the telecoms industry are probably the most advanced in terms of using this technology. This was one of the special recognition award winners from last year's another reality modelling example of inspection of cell towers. Now, these are very dangerous things to inspect if you're having to send a person up there. So these days they're sending drones up these telecoms towers, and here's a video of exactly that, a drone being flown around the telecom tower. The software now can program the drone to take the photographs in exactly the right point and fly the drone in order to capture the best photographs to be able to model these telecom towers very, very accurately. That's been an advancement over the past year or so. Now, interestingly, we're using machine learning and artificial intelligence to automatically identify assets within the reality model. Here in this case, you can see the antennae have been automatically identified, and then also the radar, the dishes, and being able to overlay where the radar radiation zones might be, so that this model has been the antennae and the assets on this telecom tower have now been automatically identified by the software. And this next bit really gets me very excited, including rust. So the software has automatically identified areas of rust up this telecom tower, and you can zoom in on the individual photographs of those spots of rust in order for the inspector down on the ground safely to figure out whether this is an important rusty bit or not so much, and be able to really categorize those points of rust, and then be able to perhaps create a report such as is shown here, as to say which areas of rust up this telecoms tower do we really need to look at, maybe change out that strut, and so on and so forth. Now,
This machine learning technology on top of the reality models is really where the software has actually got to at this stage. We're now doing automatic identification of cracks in bridges, of cracks in pipes as well, and being able to automatically identify various assets as well. So I think if I come back next year and talk to you about where this technology is at now, we'll have got to the point where you have the constant surveying and the software itself being able to bring to the attention of the maintenance or inspectors areas of concern out of all of this vast quantity of data. So here's something that we showed 3 weeks ago now at the ACHEMA event. This is the latest user interface on top of our asset performance software for reality modelling. In the process industry world, we've got to the point of automatically identifying major pieces of equipment and vessels and so on, and tying those in with your asset performance, your maintenance work orders, those kind of things, so that you can see the piece of equipment that the maintenance guy may need to work on and all its documentation based in the context of the actual plant itself. And you can see here we've linked this to the theoretical event. So maybe if this pump is causing an issue, what could possibly be going wrong with that and that type of thing. And this is a preview of this is a technology preview of this interface. We're looking for feedback from our users as to whether this works really well in a maintenance environment. We'll now start to zoom. One of the areas that we're particularly interested in is being able to relate the reality model to other documentation, like the P&ID itself. So you can see here it's zoomed in it's selected the pump and zoomed in on that pump, and now is bringing up the P&ID of the same pump. And it automatically is zoomed into that pump on that P&ID, and so that you can have, within the context of your model of your existing model of your asset, also the intelligent P&ID information and anything else that you might have associated with that. Now coming on to what we're doing with Siemens. Bentley has a strong partnership with Siemens as we're really trying to accelerate digitalization, accelerate the maintenance and management of digital twins across the life cycle of the asset. Samir talked earlier about how Siemens are modeling totally from the concept all the way through to servicing and maintenance, create an entire digital asset across the life of their particular products. Bentley, in partnership with Siemens, we provide the context in which their equipment is operating. So the factory in which it's located, the production lines, the process plant itself, the tracks on which their trains might be running, and so on and so forth. And we had last year at our main conference, the head of their information technology present about all the areas that we're working with Siemens. And here you can see those things listed out. I can go into some of them in more detail, but I'm going to focus more on the process industry side, because that's been the latest, most interesting development. Mobility is our work with them in the railways and the rail industry. Building technology is obviously heating management of buildings like this. Energy management is the transmission and distribution, electric power, gas networks. We've integrated our GIS environment with their energy management environment so that a utility company can optimize how electricity is produced and used across their entire network. That was something that's been quite difficult to do so far. And then in power and gas, they are using that we're partnering together to provide the reliability software with their gas turbine division or their power turbines division, in order to move Siemens from selling turbines to selling services. So we've partnered very strongly there. But in the process industry, we're really looking to make a step change forward in the industry. And I'm going to show you now a demonstration that we put together that was using current technology to show how this integration between the Siemens world and the Bentley world could work.
So basically, you have the monitoring of your plant, and something's going wrong, there's an issue identified, the digital twin is created, is identified, and then a replacement part is identified, and then automatically 3D manufactured, 3D printed, installed, and back to monitoring the plant's performance. So what we tried to prove is that you can, without drawings or anything like that, you can have a whole process that is totally digitally enabled with current technologies. First of all, we had the logging, the logging of what's going wrong on the plant, and this was this is using MindSphere, and we developed an application running on top of MindSphere to bring together operational data with engineering data. We have also another thing we've done fairly recently is brought the reality models into these virtual reality headsets. We're kind of still working on this area, but you can see that same reality model of the skid in the guy. He's looking around it as if he was stood by it up in that top left-hand corner, and he can go in quite some detail and look at you can see here how detailed that reality model is of that skid. He's probably in our office in Exton, and this plant is in Karlsruhe in Germany, basically. And then having identified there's a fault with a particular pump, this is an example of how Siemens simulate the pumps and as they're operating, how the pump might vibrate and move around. So then we bring all of this together. This is the Mind app. This is the demonstration I showed last year when we have the reality model within the MindSphere application. We have operational information coming through from how that plant's running, the flow rates and the electricity consumption of those pumps. You can see here pump 1 has a real problem. It's using a lot of electricity but not pumping anything. And then we've homed in on the reality model in blue what is wrong with that pump, and brought up perhaps some of the issues. Basically, the pump needs replacing. That's what I showed you last year. We went on beyond that with Siemens to then change that pump out, simulate a new pump being put in place into this environment. It needed a new vibration pad, basically, and this is all the Siemens technology in 3D, simulating the pump, simulating the new vibration pad that's needed, and got to the point of, and then they actually could 3D manufacture this vibration pad in order to change out that pump. And then we brought that new pump back into the digital twin of the asset, and to show the new pump in place with the new vibration pads attached. Now, what we had to do for that was convert the 3D model, or the reality model, into this 3D world to bring that in. But the technology is changing so rapidly that bringing just in the new reality, the new real digital model of that pump into the reality model is where things are heading very quickly. So that shows a total round tripping of identifying there's an issue of a pump, finding the pump, even manufacturing the new tie-in points, if you want, into the in the manufacturing process, and then bringing that, replacing that pump with totally within a digital world. Did you see any drawings? No, it was all done within the modelling environment. Oh, let me just go back a moment, sorry, because he starts straight away. So sorry, I'm now going to show you a video. It's a 2-minute video of what we were talking about 2 weeks ago at the ACHEMA event, going on with the process industry. How do you keep engineering information update in real time and ensure any changes like this are tracked and identified so that people know what's going on and know what needs to be changed? We have Bentley and Siemens have a vision together to create an app for that, if you like, and we've briefed ARC, and you'll see Valentine talking about this in the next video. I think Valentine presented last year here at the ARC Forum here in India, so you might recognise him. He's one of the senior analysts that knows both Bentley software and also Siemens software. So let's listen to what we've identified together and what we're doing for the process industry. Hopefully the sound.
ARC, Bentley and Siemens observed important challenges and changing requirements in asset lifecycle information management in the process industries, in particular in operating plants. First of all, there is an increasing need for collaboration and reviews across disciplines and companies. Second, handover, updates, validation and change management of asset data is poor, and as a result, information is inaccurate, inconsistent, and dated. Third, huge parts of the asset information are not being used today. We call this dark data. And finally, functional, operational, and spatial information are often disconnected. And this is important because plant reliability, maintenance efficiency, and regulatory compliance depend on accurate and up-to-date data. Overcoming these challenges would create significant potential in terms of cost savings and increased revenues of operating plants. Using digitalization, process engineering, maintenance, 3D representation and operational performance information can be integrated in new and more effective ways, providing rich context to all disciplines involved. Scalability and flexibility can be provided when implemented in a secure, pure or hybrid cloud. The accurate, up-to-date, accessible digital twin, together with best practice workflows, can reduce time to operational readiness. And this also enables continuous improvement and operational excellence, thereby improving sustainability and return on assets. Any solution must therefore support digital workflows. I recently talked with Bentley and Siemens about their vision, which emerges from the described challenges, and using possibilities provided by digitalization. The vision Siemens and Bentley described to me will be a portal in a cloud environment, which federates data from many online and offline sources, and provides digital workflows provided through a set of extensible microservices. It should ingest, analyze, validate, and link data from sources that are difficult to access, and the traceability of changes made to their data and their validation should considerably increase trustworthiness of data and improve compliance. In view of the impact it's likely to have, ARC will closely follow this project, and we look forward to report on early user experiences.
So, Valentin talked about the vision that Siemens and ourselves have for developing a cloud-based portal environment to basically keep engineering information and data the digital twin up to date across the life cycle of the application. He also talked about microservices, and Sal mentioned this earlier, that software companies are moving fast to to move on to microservices, apps that do various stuff, and that's exactly what the vision is that we're developing together now. We also announced at ACHEMA the fact that this is all very well, technology, software is all very well, but you need to change the workforce. You need to, the second speaker from NASCOM talked about 80 million skilled people shortage and so on and so forth. You're not going to create digital natives overnight type of thing. So knowing this and understanding and modelling what has been successfully done in the UK, particularly in the construction and railway industry, to take an existing fairly staid construction workforce and make them BIM natives and so on. Bentley and Siemens are joining forces to create a process industries academy. Where best practices can be shared. Your current engineers and operations and maintenance folk can get together and talk about how to use data, why data is important, and so on and so forth. So we announced 3 weeks ago that Bentley and Siemens are joining forces to create this Process Industries Academy. It's going to be located in 3 locations: Germany for Europe, China for Asia, India, and Houston for the USA. The intent is to bring expertise and in digitalization across all aspects of digitalization and get your existing people up to speed on what it means to be digital, what it means to be data-driven, and so on and so forth. And I think this is a really exciting development, particularly around developing and exploring new workflows, better workflows, and bringing everybody up to speed in terms of digitalization. We see this as really, really important. And then the final thing I want to say is this cloud-based portal environment that we have a vision for is going to be we're already working on it. We've been working on it for a good 12 months already. The technology preview of it is going to be previewed, or that's the word, is going to be shown at our Year in Infrastructure conference in October. Everyone is welcome. This is going to be in London this year. Everyone is welcome to come and take a look at what we've actually done, or look for videos and stuff like that afterwards. But this technology is very, very close, and together with the academies, Siemens and ourselves are really, really excited about what this will do for the life cycle of the process industries. So I think I'm giving you 5 minutes back, Raman. So if anyone has any questions. There's 6 minutes left. Other than that, I'm finished. Thank you.
You can't be on stage, so...